Okay, good day. This is dual enrollment pre-calculus. I am Mr. McCully, and this is lesson 38, the lesson on conic sections, specifically circles and ellipses. So today we are going to be talking about some conic sections, and we're going to recognize the basic conic sections as intersections between a cone and a plane. We're also going to talk about them as a collection of different points, and we will discuss them as we see those things. We're going to write equations of parabolas in standard form, and we're going to use the reflective property of parabolas to solve real life problems, and we're also going to start talking about some circles. So the circle is, as you know, a collection of all the points equidistant to a given point called the center. In the case of a conic section, and the reason we call it a conic section is because we are taking a plane and we are running it through a cone in different ways. And so if you think of the height of the cone, the line that goes right through the middle of the cone and hits the peak or the apex of that cone, if we run a plane perpendicular to that line, we are going to always get a circle no matter where we put it. And if you remind me in class, I have a actual 3D representation of a cone model, and I can pull it apart and show you these pieces. But the equation of a circle is always going to be x minus h quantity squared plus y minus k quantity squared equal to r squared. You might have seen that in geometry class. And in this case, hk is going to be the center of the circle and r is going to be the radius. And just a couple of things that usually trip students up is that notice that h and k are positive when we're talking about the center, but they are negative when we put them in the equation, and that the radius r is squared in the equation. And so if you got 16 here, you'd say, oh, 16 is r squared, so the radius is actually just 4. An ellipse, if we get a plane that is not perpendicular to the axis of the cone, but it still passes through the entire cone, we're going to get an ellipse. An ellipse is a collection of all points in a plane. The sum of those distances from 2 6 points is a constant. And so the way you look at it here is that no matter where this point is around the ellipse, when I add up the distance of the two red lines, I get the same value. And if you guys, again, if you remind me in class, I will show you the super fabu magic string of mathematics to find the to draw an ellipse, and you will see these parts in class. And that general equation is x squared over a squared plus y squared over b squared equal to 1. We'll talk about that in the next section. A hyperbola, if I run that plane parallel to the height line and it cuts through both of the cones that are stacked point to point, the intersection will be the hyperbola, and the hyperbola is the set of all points in a plane whose difference from two fixed points is a positive and a constant, and again, difference. And so we'll be subtracting two distances and get the same value. And then finally, the second thing that we're going to talk about today, if a plane doesn't cut through across the entire nappe or intersect both nappes, the curve of the intersection is called a parabola. And so you see it right here where we have a parabola here. And we talked about parabolas earlier on in the semester in the context of polynomial functions, and this is how we write it in terms of a conic section. And so a parabola is the set of all points in a plane equidistant from a fixed point and a fixed line in the plane, and that thing is going to be there's two equations, one for a left-right opening parabola, y minus k squared equals 4p x minus h, and the h and the k in this particular instance is going to be what we call the vertex. And then an up-down opening parabola will be x minus h quantity squared plus 4p times the quantity y minus k. And so when I say that a parabola is the set of all points in a plane that is equidistant from a fixed point and a fixed line in the plane, I am talking about essentially this thing right here. And so if I say I have a fixed point that they're going to call F and a fixed line, this blue line right here, the parabola, this red curve, is going to be the collection of all of the points that are equidistant from this focus and this thing that they call the directrix. So when I talk about this point right here, the same distance from this point to the focus as from the point to the directrix. Now, when you say from a point to a point, you're just measuring a straight line distance. When you say from a point to a line, you're talking about a perpendicular line distance. All right. So a parabola is a set of all points in a plane that are equidistant from a fixed point called the focus and a fixed line in the plane called the directrix. So when you talk about the parts of this particular equation, if we're going to try and figure those out, the h and the k, those are going to be the coordinates of the vertex, and then this p value right here is the distance from the vertex to that focus. And then the distance from the vertex to the directrix would be negative p. All right. So if I have this equation, the vertex is going to be at h and k. The vertical axis directrix will be y equals k minus p, because it's y would be equal because we have a horizontal line there. And then if you did a horizontal axis directrix, so if the directrix, if it would open left, right instead of up, down, your directrix would be a vertical line, so it would be x equals h minus p. All right, so I've got a couple of examples. I got 4 that I'd like to do. There are a lot of other types of questions that you could get from this section, and we can go through those in our class time. So I want to keep this rolling here. And so my first question is here, find the standard form of the equation of a circle with endpoints of a diameter at -1, 2, and 7, -2. All right, so let's just real quickly kind of get an idea of what we've got here. And so if I say that this point here, this is my y-axis, this is my x-axis. If I say it's -1 and 2, I've got this point right here. And then I have 7, -2. So if I come over here and say that that point there is 7, and this point here is -2, and I talk about this point right here, then this thing right here is a diameter. Now I'm not going to spend a ton of time, but we're talking about trying to find, and it looks more like an ellipse. Maybe I'll try and do a little bit better job. That's a little bit more circly. I'm trying to find the equation of that circle. Well, remember that from this first page here, if we go all the way back here, the equation of a circle is going to be x and y are going to be left in the final equation, but we need quantities for h, k, and r. So, and remember, hk is the center and r is the radius. So in this particular problem, I need to find what that point is, h and then k, and then I need to find out how long that value is right there, r. All right, so since this is a diameter, all I need to do is find the midpoint of the diameter, or one of the things I need to do is find the midpoint of the diameter. All right, so midpoint, capital N, is equal to x1 plus x2 all over 2, comma y1 plus y2 all over 2. And so in this particular instance, I would have -1 plus 7 over 2, comma, 2 plus -2 all over 2. And so we're going to see that I've already got a mistake in my drawing just a little bit. It's not going to be that big of a deal. So -1 and 7 is 6. 6 divided by 2 is 3. 2 plus -2 is 0. 0 divided by 2 is 0. And so this really would be up there if I had drawn a little bit more accurate. I had a little bit more accurate drawing there. And yeah, so that's what I would have. And so there's my center. So this is my HK, which makes that part easy, H comma K. And I need to find out what R is. Okay, well, I can find the distance from either the center to one of the endpoints. And it doesn't matter which one I choose, so I'm just going to choose this one right here. And so the distance, which is going to end up being R, is the square root of the difference from those values. Now again, this was 3, 0. So if I want, and this point right here was -1, 2. So if I go 3 minus -1 quantity squared plus, let's see here, it would be 0 minus 2 quantity squared. I do that in the right order. I think that's going to be okay. So I go square root of, let's see here, I get 4 squared is 16 plus 2 squared is 2 squared is 4, so I get the square root of 20. That's R. Now remember, in the final answer, we're going to go x minus h quantity squared plus y minus k quantity squared equals R squared. So normally I would say if we're going to put this as our final answer, we should simplify this, but we're going to square it anyway. So the square of a square root is just that number, right? Because the square and the square root cancel out. And then we already know that h and k are 3 and 0, so I'll go x minus 3 quantity squared. But I wouldn't write y minus 0, because y minus 0 is just y, so we're going to go plus y squared. We're going to put a box around that one and be done. The next example here is write the equation of circle in standard form and then find the center and radius. And so this is the general form of a conic. And we know that it's a circle because the x squared term and the y squared term are the same. And so we are going to put this back into this particular form. If it'll go back. Come on, go back. There it is. This x minus h quantity squared plus y minus k quantity squared equals r squared. We're going to put it in that form by completing the square. So I want to reorder this. I'm going to rewrite with some space. So I'm going to go x squared plus 8x. Let's see. I'm going to put a little space there, and we'll go y squared plus 2y. Put a little space, and I'm going to move the constant over and -8. And so the reason that I have this, and I'm going to erase this just a little bit so it looks a little nicer. I'm going to complete the square. And we're going to complete the square for this 2x, or excuse me, x squared plus 8x. And so if you remember back from Algebra 2 and our completing the square earlier on, what we're going to do is we're going to add half of this value squared. So half of 8 is 4, but we're going to square that. Now, because we've added it on the left-hand side, we have to subtract it away on the right-hand side. So let's see here. I'll get minus 4 quantity squared. And then I want to add half of this squared. I'm sorry. I said something incorrect. I've got this written wrong. if I add it to the left-hand side, I also have to add it to the right-hand side to keep it in balance. I said subtract it away, and that was incorrect. So I want to fix that. So I'm adding half of 8 quantity squared to both sides to keep my function in balance, or keep my equation in balance. And so I want to do the same thing with this 2. I'm going to add half of 2, which would be 1, squared, and then I want to add it to this side squared to keep it in balance. So now I have 2 perfect squares on both sides. This first perfect square is x plus 4 quantity squared. This second perfect square has to be y plus 1 quantity squared. And then I've got 9 plus 16. 9 plus 16 is 7. 7 plus 1 is 8. So I have 8 there. So my center, S-E-N-T-E-R, is going to be -4, -1. And then my radius will be, let's see here, I don't need a parenthesis, ADIUS, will be the square root of 8. And the square root of 8 we know to be 2 square root of 2. Yeah. And I'm going to check my math real quick here, because half of 8 is 4. 4 squared is 16. 16 minus 9 is 7. And then 7 and 1. So I guess that's I'm going to go with that. That is my answer for that particular problem. Okay. Next one, it says find the standard form of a parabola that has vertex at 2, 4 and a directrix of x equal to 0. So again, just so that I can see this stuff, I wanna draw my diagram here. And so I have a vertex at 2, 4. So at 2, 4 right here, I have a vertex, and it says the directrix is 0. So I'm going to draw this in red so that we can see it. So this is my directrix right here. And so my parabola, since its vertex is right here, it's going to open like this. And since this thing opens up, all right, since it opens up, for every 1y, we have 2 different x values. That means that this is an up-down parabola. And when we talk about the equation that we're going to use to it, because there are 2 x's for 1 y, you know, that's how I look at it. You don't have to, but you could say that this is an up-down D-O-W-N, dummy, Cully. And this would be a left-right. Parabola. If you wanted to, you could do it that way, but that's how I look at it. So I'm starting with x minus h quantity squared equals 4p y minus k quantity squared. And so remember, this distance right here is -p. So in this particular instance, -p is, let's see here, if I go that way, -p is, so I'm at 4, so equals to -4. So p equals to +4, because again, we're going in this direction from here to here, -p. And it looks like that's all I need, because I got my h and my k. They give it to me. It's this. Here's my h. Here's my k. So my final answer is x minus 2 quantity squared equals -4 times, or excuse me, it'll be +4 times 4 will be 16, and then y minus k is 4, so y minus 4, and then this shouldn't be squared. I made another mistake, and I apologize. That's 2 in the same one. There we go. That should not be there. And that's my final answer, so I'm happy with that. All right, next one. Write the following quadratic in standard form. List the vertex, focus, and the directrix. And here is, again, a general conic section. The reason I know that this is a parabola is because I have an x squared and no y squared. You could also say that it would be a parabola if you had a y squared but no x squared. And so I know that I'm trying to get a parabola. And so that parabola equation, again, looks like that. And since the x squared terms, so I'm going to leave my x terms on the left-hand side. I'm going to move my y terms to the right-hand side. Come on, go back, please. It'll do it eventually. There we go. And so let's see here. I'm going to go x squared minus 2x and equal to negative 8y, and then we'll say plus 9. Okay. And so I need to complete the square. On the right. And so I'm going to add half of negative 2. Half of negative 2 is 1 squared. And so we're going to add negative 1 squared to both sides there. And I think I have a mistake. I subtracted 8y from both sides, but I didn't subtract. That would be dumb. And so let's do that. I should subtract 9. There we go. And so now this is the perfect square, x minus 1 quantity squared, and then I get negative 8y, and then this will be negative 9 plus 1 is negative 8, so I'm going to factor that out, and go x minus 1 quantity squared equals negative 8, and then it'll be y minus 1. All right, so since this thing here is an x squared, it's an up-down parabola. And so if I think of it in terms of that equation, remember it's x minus h quantity squared equals 4p y minus k. And so I can say that my vertex is going to be 1, 1. And that 4p value is equal to negative 8. That means p is going to be negative 2. So I've got a parabola that opens down. So just a quick visualization. I've got a parabola at 1, 1. Just a second. All right. I've got a parabola at 1, 1, and it opens down like this. Now, P is negative 2, so that implies a direction. To the focus, that's going to be P equal to negative 2. So if this point right here is 1, 1, and I go negative 2 down, this point right here will be 1, negative 1. So my focus is 1, negative 1. And then this distance right here is negative p to the directrix. All right, so that negative p right there to the directrix is 2 units, and so I go up 2, and if the y value here is 1 plus 2 more units, my directrix will be a horizontal line that makes it a y equals, and then 2 units above 1 would be 3. And so there are all of the things that they have asked me to find. All right, that's all I got for today. The Star Wars fun fact of the day: lots of hands were cut off in Episode 3, Revenge of the Sith. Sorry, Count Dooku lost 2 hands to Anakin. General Grievous lost 2 hands, although they were robotic hands, to Obi-Wan. Mace Windu lost a hand to Anakin, and then Anakin lost 1 hand and 2 legs below the kneecap to Obi-Wan. That's all I got. Have a good day, folks. Goodbye.